All right, guys, today we're talking about normal distributions. Another way to look at that is when you take a bunch of data and you put it together and you analyze it. If you take that data and you group it together and you create a histogram out of the information, sometimes you get what is called a normal distribution, and it looks like these three examples below. In general, in the middle-ish, you get the bulk of the data, right? The average data, there's a lot more numbers around the average because that's why it's the average. It's usually the center. And then from there, the data slowly teeters off to the sides. Now, a normal distribution is not always symmetrical. The one on the left, if you notice, you've got these data points. There's a lot more data to the left of the peak. We call that skewed left. The one on the right, there's a lot more data to the right of the peak. That's skewed right. But it's still a normal distribution. You've got a peak, and then the data kind of dwindles down as you go off to the side. This skewed left, skewed right, and symmetric, when it asks you to characterize the basic shape of a distribution, these are the words that you're looking for. When you look at the histogram, you want to say it's skewed left, it's symmetric, or it's skewed right. Now, what makes these histograms it's kind of like a bar chart, but the different bars that represent the data are all side by side and touching each other. That's called a histogram. So what we're going to be doing today is, first of all, we're going to be creating these histograms, and then we are going to decide if what the basic shape is, if it's a normal distribution, and if it's skewed left, skewed right. And then we're going to also analyze the data a little bit as well. So we've got a frequency table over here on the right. And it's grouped all of the data for us. So on the left, it says the number of tickets sold, and then it tells you how many tickets were sold. So when you're making these charts, sometimes people get confused on where, like, your chart's got two axes, right? You've got the one that goes up and down and then the one that goes across. The frequency is the up and down. That's how many times that category shows up. So when you're reading this chart, there are 5 people that that sold between 1 and 8 tickets. There are 25 people that sold between 25 and 32 tickets. That's what this chart is saying. So the frequency is what goes up and down. That's what determines how tall your bars are. And then the number of tickets sold is the category going across the bottom. Now, there's a couple of things that are really important when you are making this histogram. And they both have to do, 2 of the big ones have to do with designing the chart to begin with. First of all, the width of your categories. If you notice 1 to 8, 9 to 16, 17 to 24, 25 to 32, each of these categories is separated by 8 numbers. That's perfect. If you see a histogram where all of a sudden one of these categories does something like 9 to 50, that's a sign that the data might be being misrepresented, okay? So your categories need to be separated by the same value. And then going up the side, your frequencies also need to be consistent. So you can't say this represents 1, this represents 10, this represents 100. The distances going up the side also needs to be consistent. So if this is 1, then this needs to be 2, and then 3, and then 4, all right? So when you're making these charts, just be careful that you're checking those 2 things, that you're making the widths of your categories the same, and that you're keeping a consistent pattern when you are making your tick marks to go up. So this first histogram should be pretty easy because it gives me the categories and how often they show up. So number of tickets sold, 1 through 8. So at the bottom, I'm going to say number of tickets sold. And I might need to make this a little bit wider. And I'm going to go 1 through 8 right here. So this is 1 through 8 tickets, and there were 5 tickets sold. Let's see, we've got to go from 5 all the way up to 25. So let's maybe count by 4. Let's say this is 4, this is 8, this is 12, this is 16, this is 20, this is 24, this is 28. And I think that should be tall enough. So this first one should go up 5 because there are 5 people that sold 1 through 8 tickets. So 5 is right about here. So my first bar would go up to 5. My second group is 9 through 16. So I'm going to try to go the same width. And I'm going to say 9 through 16. And this one goes up to 9. So it goes a little bit taller here. And then my next group is 17 through 24. And we want it to be about, maybe I should just mark all of these now and try to keep them the same. Now, when you're doing this by hand, the computer's way better at doing it than we are. But just do your best to keep it consistent. If you were making a computer-generated one, it would be even more important that these categories were all done correctly. So 17 through 24, 25 through 32 goes up to 25. And then it looks like our values are going to start going down. So 25 through 32, 33 through 40, 41 through 48, and then 49 through 56. All right, so the next category goes up to 20, which is about there. And I'm probably not right on, but we're close enough. 8 is going to be down here, and 7 is going to be just underneath it. So when you look at this histogram, it looks like a normal distribution. You've got a peak, and then it kind of gets lower to the left and lower to the right. Now, to be symmetrical, that doesn't mean that every single bar, that this one and this one have to be exactly the same height, and this one have to be exactly the same height. But when I look at this chart, it looks pretty symmetric. This one and this one are pretty close. This one and this one are pretty close. This one and this one are pretty close. So I would say that this is a symmetrical distribution, okay? Most of the data is there in the middle, and it peters off to the left and the right. Okay, the next one gives me, what are we talking about now? The numbers of pounds of aluminum cans collected by classes. Okay, so when I make my chart, I've got my 2 axes I've got to make. My lowest number is 7, and I'm going up to 35. So maybe let's count by 7s. 7, 14, 21, 28, and 35. 28, 35. And then my numbers across the bottom, I'm going up by 10. And there's 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So this is 1 through 10. This is 11 through 20. This is 21 to 30, 31 to 40, 41 to 50, 51 to 60. Okay, so when I make these charts, 1 through 10 goes up to 7. 11 through 20 goes up to 8. Now these ones are going to be a little bit harder to get. I didn't pick very good numbers to count by, did I? 21 through 30 goes up by 10. So that's got to be bigger than the 8, but not up to the 14. 31 through 40 goes up to 16. So I got to get above the 14, but not up to the 21 yet. 41 through 50 goes clear up to 34. Holy smokes. Okay. So that makes a big leap. And then 51 to 60 is down back at 15, which is somewhere around here. Yeah, maybe pick better numbers than me. Now, when I look at this one, well, when you're drawing these on paper, you're going to use a ruler to kind of help you out and make sure you're staying consistent. But when you look at this, the peak is over here on the right, and that's okay. The peak doesn't have to be right in the middle. And there's a lot more data to the left than there is to the right. So this would be a skewed left distribution because that tail goes to the left. Now, what that means is a lot of different things depending on the situation. It's not as normal as a symmetrical, right? You don't have that average right in the middle and then it kind of peters to the left and the right. This one, you've got this large group of people that did 41 through 50 pounds. And then you've got a bunch of classes that did smaller numbers than that. And so the average is going to get pulled by that one really tall data point. Even though that's really far to the right, there's so many values. There's 34 in that one spot. This one only has 7. This one only has 8. This one only has 10. This one has 16. So all 4 of those combined on the left have a little bit more than the one on that big one right there. That's the tallest. And so you've got a lot more data spread out below that group that is the biggest group of the data set. Okay. Now, the reason this distribution matters is because depending on the shape, ethically, there's certain numbers that you should use to describe the data. Now, I'm going to say that again. Ethically, there's numbers that you should use. That doesn't mean that companies and politicians and salesmen will use this data ethically. But if the data is symmetrical, then this chart over here tells you that you should use the average and that you should use the standard deviation when you talk about the data, because the data is spread out consistently to the left and the right, and it's kind of grouped around that center average, right? But if the data is skewed, you should not be using the average when you are telling customers about the data. You should be talking about the median, and you shouldn't be using the standard deviation when you talk about the spread of the data. You should be using the 5-number summary. So the chart is great to look at, but it also gives you information and helps you understand ethically what would be the right information to use if you are presenting this data to somebody that is interested in what you have to present. All right. So hang on to this chart. This is something that you're going to want in your notes. I don't expect you to have it memorized in one day, but it's something that you're going to need to know going forward when we are analyzing data. So these next couple of sections, these next couple of examples, I'm losing my voice. I'll try to make this quick. It gives you data. It wants you to draw a histogram, and then it wants you to measure the center and variation. It wants you to state which measures of center and variation would be the best. And then it asks you to determine interpret some piece of data within that group of data. So first of all, we got to draw the histograms. Now, I already went through and I kind of put these into categories so you didn't have to sit and listen to me do it over the video. I maybe should have just drawn these histograms already. But this first one, this histogram is measuring a police officer that's radaring people speeding. So there are 6 different categories. So 1, 2, 3, 4, 5, 6. So we've got 31 through 35 miles an hour, 36 through 40, 41 through 45, 46 through 50, 51 through 55, and 56 through 60. Now the frequencies, they go from 1 all the way up to 11. So I'm just going to mark each one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each of those tick marks represents one person going that speed. So when I draw this chart, there was one person going between 31 and 35. Does it tell us what the speed limit was? Oh yeah, the speed limit is 45. Never mind, that we'll get to that later. So 31 to 35, there was only one person going that speed when the police officer was radaring. 36 to 40, there were 3 people going that speed. 41 to 45, there was 5. So let's see, 4, 5 goes right there. 46 to 50, there were 6 people going that speed. So just a little bit more than the group below. 51 to 55, there were 11 people going that speed. And I apologize if my heights aren't perfect. You'll be using a ruler, so yours will be way better. 56 to 64, there were 4. All right. So when I look at this, the data is skewed, right? Here's the high point. There's a lot more data to the left than there is to the right. So I would say that it's skewed left. Whoops, that's not how you spell left. Because that's what it means by, did it ask me to, nope, it didn't even ask me. But it is skewed left, which means to measure the center and the variation, I should not be using the average. I should be using the median, and I should be using the 5-number summary to describe this data. The average and the standard deviation would be a misrepresentation of this data, all right? Now, the question below says the speed limit is 45. 45 is right about here. How would you interpret these results? Well, when you look at the data, there's about the same number of people going just below as just above, right? That 5-mile-an-hour range is pretty even, but there are a lot more people. This is 11 people. This is 4. Over here, you've only got 1, 3, and 5. So when you look at this data, there are, 21 people that are speeding and only 9 people that are going under the speed limit. So my interpretation would be a lot more people speed, and it looks like the group that's the biggest goes 5 to 10 miles per hour over the speed limit. And if you think about your own driving, that's probably pretty true. Most people go between 5 and 10 miles per hour over the speed limit, which is why our speed limits are so low, because they know that. They know that most of us go 5 to 10 miles per hour above the speed limit. All right, next group, email attachments. These are email attachments sent by employees. So if I do the same chart, we'll try to get this one done quickly. We've got 6 groups again. So 1, 2, 3, 4, 5, 6. 1 through 20 email attachments, 21 through 40, 41 through 60, 61 through 80, 81 through 100, 101 through 120. Now, last year on this lesson, I had a lot of my students get really lazy with the labeling of the chart. And to me, that is the most important part of this chart. These labels across the bottom and the labels going up the side, it's important that they are correct. And it's one of the most important pieces of information when people are looking at your chart, okay? Don't get too hung up on, where the height of your bar. If your numbers at the bottom aren't correct, then the height of your bars don't mean anything, right? So take the time, make sure you do these charts correctly, make sure you do them well. You're not trying to record a video for a class and speed things along, right? So we got to go from 2 to 10. So again, I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, my first group, 1 through 20 goes, there's 2 people that sent 1 through 20 emails. There are email attachments. There are 3 people who sent 21 to 40 email attachments. There are 9 people who sent between 41 and 60 attachments. There is 10 people who sent, listen to my voice go, 61 to 80. There is 4 people that sent between 80. That's about right. 81 and 100, and then 2 people that did 100 to 120. Now this one's a little bit interesting because there's not one peak in the middle. These 2 together are kind of the peak, right? If you were to find the average of this data, it would be probably right between these 2 big graphs. And so I would say that this diagram, even though there's not one peak, those 2 peaks in the middle are pretty close, that I would still say that this is symmetrical. I don't think this is skewed left or right, which means I could use the average, the mean, and I could use the standard deviation when I discuss this data. Because it's symmetrical, I can use those numbers and feel okay about what information I'm representing when I use those numbers, all right? It doesn't ask me anything about numbers. All right. One more diagram. 2 more diagrams. We better go through these real quick. At least we don't have to draw them. The double histogram shows the distribution of emojis sent by a group of female students and a group of male students during 1 week. Compare the distributions and appropriate measures of center and variation. So if I look at the female group is pretty symmetrical, right? There's the peak in the middle, and it dwindles to the left and the right. The right side might be a little bit heavy, but not dramatically so. So I would probably use the mean and the standard deviation. But when I look at the male students, this is very much skewed to the right. The data is mostly on the left side of the diagram, and the tail is going out to the right. So be careful when you are using this information. Sometimes we get the names backwards. Remember, if it tails to the right, it's skewed to the right. And the bulk of the data, the big pieces of the data are there on the left. So since it's skewed to the right, I would want to use the median, and I would want to use the 5-number summary to describe this data, all right? The one below, you've got professional football players' experience and the experience of company employees. Obviously, the company employees is a lot more symmetrical. The football players are skewed to the right. There's that tail of players that play for a really long time, but most of them look to play between 3 and 8 years, and then it kind of dwindles down and is skewed to the right because of those couple really long career players that pull that data out. So if I was talking about football players, I wouldn't want to talk about the average length of their career. I would want to use the median length of their career. And employees at a company, I would be okay to use the average because that data is symmetrical. All right. We'll talk about these. If you are in class, we're going over this stuff in a little bit more detail. I try to keep to the basics when we're doing these videos just to try to limit how long it is. I know this one's a longer one because you had to sit through me making diagrams, but you'll get over it. So 7.3 exercises is the homework, and you are doing all of these questions. There's 18 of them. Read them carefully. Make sure you do all the different parts, and come see me if you need any help.